Hi, everyone. My name is Kelly Chang. I'm a postdoctoral research scientist with Ariel Rokem. I'll be one of your instructors for a few of the sessions for the rest of this week. So if you're here, hopefully we all figured out that this is the intro to Python. So if you know enough about Python and you want to learn about the more advanced things, we should probably be in room 103. Otherwise, we're going to go through fairly basic fundamental things. So hopefully everyone's been able to access the Jupyter club. Yes.
Some people are having trouble pulling images, like it's just taking a while. Probably it just needs a few minutes to go, so we'll check in a minute. Make sure.
Okay, yeah, I'm not moving my screen or anything, so whenever that lag sort of clears up, I'll maybe make this screen a bit full screen. So hopefully everyone's been able to access the Jupyter Hub, and so you can sort of see that on screen right now, hopefully also on Zoom as well. It's just a quick rundown for people who are unfamiliar. When you launch your Jupyter Hub, basically, you'll get a file browser on the left-hand side. I've navigated to where you guys would probably be when you first land here, as well as this launcher. And if you don't have this launcher, you can just sort of press one of these tabs and it'll just open up a new one, where you have a few options where you can start a Python notebook, can start a interactive Python console, as well as a variety of other things as well, as including the terminal, text file, markdown, etc. And as well, these aren't the only things, these are just like the quick shortcuts they provide for you. So if we navigate over, am I okay to start moving things on my screen?
You may just need to review it, but they get joined.
Okay, I see a hand, yes.
Just curious, is this applicable to all Jupyter, or is it specific to the Neurohack?
I see. So if you have a Jupyter's, this is, I believe, is the Jupyter Lab instance. Whatever instance that you run on your local computer, let's say, it will look very similar to this. However, we're just hosting it off of the web browser here. Now, if you guys also, one thing I should double check is, can you people in the actual room see this font size? I can increase it. Or do you want it to like, is this okay? Okay, I got some thumbs up. Excellent. All right, so if you navigate over to the curriculum folder, just double clicking it, and we can also make this expand out wider. You see that my last name is Chang, so Intro to Python. We have a few notebooks here available for you to have and to hold, as well as a small data folder in here if you wish to. If you open up any of these IPy notebook extension files, you'll basically get a markdown with a bunch of code embedded inside. And this will be primarily how you can read through these notes. I have these up here for you to read through at your own leisure. Otherwise, but having me up here, hopefully we'll do this a little bit more interactively rather than me just going through some lecture notes. But just in case I go through anything too quickly, these are here for you to read at your own pace, either later or even during. You can also take some of these code chunks that you can sort of see here, but I'm double clicking. Let me get rid of this real quick. Turn off forever. You can also copy and paste into your own notebook as well, so you don't have to type everything as I'm typing. All right, so these are just, again, just for you to have. But let's actually sort of open up Jupyter Hub as we would if we wanted to start a new notebook. You can do that by just clicking on the shortcut I've mentioned here. And immediately in our file browser, you'll see it populates an untitled IPython notebook, and I'm just going to rename it with intro, just so I have a more sensible name.
I think there's actually quite a few still loading books, so
okay.
I don't know if you can show like Jupyter.
Yeah, for sure. People seem to be like loading their instances, and that does take a while. So as people who probably try to figure it out is known. So there's a few things I can talk about in terms of the Jupyter notebook. You can also see that there is a bunch of other drop-down menus here. You can actually open a lot of things. While you can save your notebooks from here, you can open notebooks from here. You can also open stuff from URL over here. So if you actually have things that are hosted on GitHub, let's say there's a Python notebook in their GitHub repository, you can load it from here as well. Something that might be interesting to note for people as we probably use this lab is that you've sort of noticed, right? When you close it down, sometimes it closes forever, and then like you have to go scavenge for it. And these files aren't actually on your local machine. You can actually download these files. So you just saw that intro Python notebook go to download. So if you wanted to download something, just do that real quick and you'll have it on your local. Yes.
The file, I think, are you able to just open it on your computer, or do you need to have a Jupyter?
So you don't, well, you do need to have some sort of interactive development environment in order to open it. I have Visual Studio Code, and I have set my computer such that when I open that IPy notebook, essentially, it'll populate right here. You can sort of see because we have nothing here. It opened up my VS Code just the same. There is, oh God, where are we? Where there is, I believe, I think there's a Jupyter Lab app. I don't use it, but because I use Visual Studio Code more predominantly, but you just need some sort of interactive development environments. I do recommend VS Code. Most people here, I think, most of the instructors here use it to some capacity or another. This also goes the same for things like Python. Like this opens an untitled.py script as well. Type, download if you want to work off this hub and then keep your stuff. Because at the end of the course, this does get wiped. So if anything you want to save, please do download these things. Okay. I gave it a moment. Are we still doing okay? Bunch of other drop-down options that we'll sort of get to as we get there. I guess there's also something to show here while people's instances are loading, is that sometimes the terminal is quite useful. If you take a look and I guess the question is, how many people have navigated with a terminal before, either on a Mac, on a Linux, or in your command prompt on a Windows? I see some hands, excellent. So essentially, Jupyter Hub runs off of a Linux kind of kernel. And so those kind of Linux appropriate commands will be the ones that will pull up what you need. So right now I have my terminal. You can see the blinking cursor. If I type pwd, forget my current working directory, my current home is home Jovan, just for short for the home directory. And I can navigate into the curriculum, let's say with CD, go into that curriculum directory, ls to look at all the folders inside, and so on and so forth. So you can actually also call other relevant bash-like commands or terminal-like commands from your terminal here as well. Fingers crossed that people have navigated, hopefully, to their kernels. Okay. If you'll forgive me, I do have to push forward. So if you have any questions about anything I covered while you're waiting for your server to load, please contact me on Slack or in person if you're one of those people here, and we'll help you get that sorted out. All right, so again, hopefully everyone in this particular part of the lecture tends to come to this intro to Python at various different levels. Either you have zero experience with Python or coding in general, or you have zero experience in Python or minimal experience in Python, but you have like expertise or proficiency in another language. Could I get a really quick hands just to see like, what do people know some other coding languages, or are you just complete novices? Okay, some other languages. Do you mind telling me what kind of languages they are? R? Okay, no MATLAB? Okay. I was just like, some people have to know MATLAB. I see you in the back. And so, okay, great, excellent. So I don't have to cover like the super duper basics, like what is a variable, what is that kind of thing, but I will expose to you some Python-like syntax essentially, just to get you a bit more familiar with how to translate things from, let's say, R or MATLAB or other coding languages that you might know into Python. So first things first, making variables is pretty simple. Unlike R, most people mentioned R, so I'm going to use it as a touchstone here. No arrows, just an equal sign will give you your assignments. You can assign any variable to be, of course, their usual numerics. So an int. I'm also realizing I am myopic, so I need my font size on my personal screen to be large. So I'm closing my file browser and also making this extraordinarily large. You can have floats, integers. You can have floats, right, with decimal points, my variable. You can also have strings. Now, strings come in either double quotes or single quotes, so long as you're consistent, both are okay. So a string, stuff like that. So just as remember as a touchstone, these are the singular variables. To run things, so to run this cell that you see highlighted here in this blue outline, you can either use the shortcut on your keyboard with Control-Enter. You can sort of see that the cell has completed running when you see a number form. If it was still processing, it would be an asterisk. There would also, sometimes also, if you want to see the last thing printed out, you can have the variable or whatever thing you want on the last line. If you also run this again, you'll also have it print. So I believe R is really similar, and with MATLAB, it would be unsuppressing that semicolon at the end of that line. So one thing that's really nice about Jupyter, and especially notebooks in general, is that you can break your code sections into chunks. You can also, as I sort of showed you before, I just moved my mouse down here and clicked insert new cell. You can also have a separate cell to do other additional operations and keep those things separate. You can also rearrange them and rearrange. You saw, I just clicked the up arrow here just to drag and drop my cells if I wanted to do some reordering. If I was coding chaotically and not in order, I can reorganize them afterwards. So just wanted to let you know that we have our usual variable types and characters in Python as we do with everything else. Mathematical operations are also equally similar. So if I do 12 plus 2, I just run that, we have our usual mathematical operations. Something to note that might be a little bit different in Python, I'm going to recall this so I have a string again, is that oftentimes in MATLAB and R and other languages, you're thinking functions first, right? If you wanted to say, let's capitalize this, my variable, a string, into uppercase, usually we would call something like this, like upper my variable, if I could spell. Right, we usually think of it as function first. And if I were to run this, we actually get an error in Python. And that's because Python's more of an objects-based coding language first. So we're thinking more methods and attributes rather than function first. And you'll sort of see why this is more relevant as we talk more about other packages you might encounter in Python and how they decide to code the way they code. So my variable, once again, if I could spell. Instead, we use the method type of notation where we do the variable dot the method name. So think of it as reversing from function to method at the end. If upper really does just capitalize my entire string. It's just, so instead of doing the function version of it, let me just make sure I keep typing this. Upper my variable. This up here, and with the comment, sorry, that was a command / that was my quick shortcut for comments, or you can also just annotate that aside with a hashtag. And this will throw you an error. Whereas this is sort of the method-based way of going forward from it. Similarly, there are other string-based methods. So, right, we can also have lower be the same thing. Please note that these are for, what I mean by object-based is that my variable is currently a string. I'm going to copy this just to make sure I don't throw an error even more down the line. Is that if I have my variable be a number, let's just say 5. Let's see what happens when I try to use my spelling abilities. If I try to do upper on an integer variable, it doesn't actually have that attribute. So if you take a look at the error message right here, first off, it shows you what line that the error message is thrown upon. It's on the second line within this cell. That's one thing to note as well. If you're used to coding in a giant IDE, is that the number of the line number refers to the cell that you currently ran. Is that the error is attribute error. Int object has no attribute upper. So the difference between this cell right here that I'm circling with my mouse versus this cell that I'm circling with my mouse down here is that the variable was originally a string. Strings have specific attributes or methods associated with them. They can be uppercase, they can be lowercase, they can capitalize, they can be combined in different ways. However, when my variable is an integer or a numeric, what does it mean to have an upper? It doesn't. It doesn't have that attribute. And so these kind of methods will be associated with the type or class of data you have. And this is sort of a very Pythonic way of thinking or object-based coding, where we have the variable have a class type and its associated class will have us associated with methods and attributes. And how can we inspect these kind of attributes? Well, first we can inspect the class. So my variable, my R is showing as well. Type is the, once again, please spell correctly. If you ask for the variable's type, you'll have int. If my variable was a string, it would say str for string. And so you can inspect the type using the type function. This is, again, I'm using like basic dummy examples where we're talking about ints and strings, but this can get more complicated when you start writing your own class definitions. And we'll see that with other packages because packages define their own class types, and this will get their associated methods and attributes will be a little harder to immediately intuit. Another way to inspect what kind of attributes are in my variable is the dir function, dir. If I hit run on that, you'll see that it actually prints out a bunch of different attributes, including these underscore types of methods as well. And I gotta keep scrolling. There's a few other fun ones here where we can actually change our int to bytes, 2 bytes from bytes, grab our imaginary numbers from our integer. Yes.
Someone asked on Slack, if you would explain why we should use Python versus other languages.
Okay, excellent question. Let me finish off my first thought and then we'll go from there. And so, right, these are associated with integer data types and classes. And this entire bucket of attributes will be different if I were to print out a string, let's say. And so to refer back to why we want to use Python over other languages, so if we want to compare it to MATLAB, well, MATLAB is not free. There is also the
Compared to C.
compared to C. Oh, that's a hard one. Well, C is impenetrable, but for a beginner sometimes. I think Python is more used in science these days because of its open source nature and because of its Swiss Army knife-like nature. It's good at almost everything. It might not be the best in exactly everything, but it can interface with almost everything else.
Is C not open source?
C is open source, but Python also interacts with C through Python. So it can actually interface with base C code without you having to write C.
Does C interface with Python?
It does. Yeah, it does. So
why use Python?
because learning C is hard. I also think
Harder than this?
I think so, actually. There's a lot of differences in terms of having to understand memory allocation as well as operating systems. That gets a bit obfuscated. That can be covered up a little bit with Python
Does that make
interactions.
you efficient and disciplined?
I think it makes you think efficiently to try to get your code done, to get your problem solved. I don't know if everyone wants to interact at the base level. I think if people want to learn more up to that level, people will learn the coding language. Like people will then okay, I need to fix the Python code. I will have to learn C. Like that's more of a second level rather than an introductory level. I think learning Python as an intro is really good because it makes you understand coding at a fundamental level first before you have to interact with it at a byte level, I think. At least that's how I felt when I was learning these languages in that order. As for other things, is it's also because there's a lot of packages that are already openly available, as well as you troll through GitHub. There's a bunch of Python libraries. You can, hopefully they have a paper on it. Hopefully they also validated it. Hopefully, a lot of other things. You can also read the code as well. But it's stuff like NumPy. It's stuff like SciPy, packages you probably all have heard of that are really well validated and really well tested that people can really quickly use and implement without having to basically reinvent the wheel. I don't need to reinvent how to do a Fourier transform in Python kind of thing in order to just use it off the bat from, I believe, SciPy. Hopefully that answers your question, whoever was on Zoom. I will say though, if you know other coding languages, it helps a lot. Like I said, Python's a sort of a Swiss Army knife. It does everything well. Some things excellent, but not everything excellent. So there's different coding languages for different problems, I think. Okay. Thank you for your questions. So we also have other attributes that you can dig through for all of your different data types, just to make sure I've covered my bases. That is a long thing to scroll past. Voila. We also have our traditional Booleans as well. So our trues and falses. Trues, again, my R is showing through. Trues and falses are only capital case. So true and false, only T and F are capitalized. You might be familiar with other languages that also capitalize the whole thing or don't capitalize anything, but essentially just as a capital case. Yes, I see a hand over here on the left.
Sorry, I just had a quick question.
Of course.
Is the method you've been using for method and attribute, are they totally synonymous or do they mean different?
I in my mind think they're different. For me, methods are more function-like, attributes are more like data types. When we write our own classes, that's how I differentiate them, but some people don't really do that strictly, I would say. So sometimes, so long as it can be dot something, you can sort of access it. So I personally think that if it does something, whether in place or not, I think it's a method. And if it's oh, what's the shape of this thing? I think that's an attribute. It's just a property of the class object. Okay, so just going through very quickly the different data types that are at the most basic. We also then have our lists. So lists, my list. We have square brackets as our notation, and lists, as they imply, can sort of contain anything. String. So long as they're bracketed in, doesn't have to be of a certain length or whichever. So if I just print my list, oh. Excellent moment. Also reading syntax error, invalid syntax, perhaps you forgot a comma. Python is pretty verbose about its errors. And if you don't understand its errors, you can always copy and paste it into Google. And for the most part, somebody on Stack Overflow will have the same question as you. So you have lists, they don't have to be of the same data type. That's something of note here. You can have lists of lists. You can have whatever configuration of lists that you would like. How would you access lists? Lists are the ordered type in Python. So my list, and something that might be of importance to note and something that beginners often forget, Python is zero-based. So the first value in your list is 0. Can be accessed with the 0 and the square brackets. So my first item in my list, or my 0th index in my list, is 1. Please keep in mind, I often forget when I go back and forth between languages. And so there's other things that you can do, such as just knowing some basic functions like len is for length of list. Oops. Len for length. So I have 5 items. 1, 2, 3, 4, 5. I do have 5 items. I try to do this, and it tries 5. Please note also, right? If I wanted to access the last item, I can't actually call them a length. I would actually have to do a -1. So, right, zero-based indexing, length of list does not actually work for the length of your list. A little frustrating sometimes, but useful to know. You can instead access things from the back by doing a minus instead of going forward. You can go backwards with a subtraction. So you can now access the last item, or you can do the second to last item, right? Going backwards, counting from the end. Cool. And so lists are the ordered items, and you can access them with the square brackets the same way that you've assigned them. Sometimes you will see other people in their code, they might actually initialize a list by calling list the function, same kind of thing. You can also do this similarly with square brackets. You've probably seen these kind of things before. The other type of ordered item in Python is called a tuple. My tuple, this might be a little bit different for you. So 1, 2, 3. Ooh, I'm gonna try to do the same thing. True string. Okay, excellent. This, instead of having the square brackets, you have in parentheses instead. And the one thing about tuples that makes them different from lists is that tuples are immutable, whereas lists are. And what I mean by immutable is that once you've constructed a tuple, you cannot change the items in the tuple. So if I tried, I can retrieve the things from the tuple. So once again, I can call on the first item and have it print out 1 for me. But if I wanted to say, assign that 1 to be something different, so let's make it 10, it'll yell at me and say type error, tuple object does not support item assignments. And so we can't change the tuple values that we've assigned. We can, however, do that with a list. If I go back up this one cell, my list, I want to reassign that first thing to be 10, and then print my list just to show it to you guys. You can actually mutate list types. So be careful. Sometimes people, when they program, if we interact with other packages, sometimes they request, like, they're okay with requesting like lists or tuples as arguments for other functions. And if you do one or the other, you just notice that you can't change one or the other after you've assigned them. You can see some benefits to this where it's like it gets more closer to like a constant or a variable that you don't want to change. I don't know. So like maybe if you're working with fMRI data, maybe the shape of your bold data is something that you don't want to ever be changing. And this might be something to be used as a tuple rather than a list. Okay. So we have those things. One second. Okay. Any questions so far? I'm speaking quite quickly. Okay, cool. Another really useful data type for Python to know are dictionaries. I'm not going to type out that much. Curly braces instead. We have curly braces, and then for dictionaries, much like structures in MATLAB or data frames, sort of in R, they have a field and their associated values. So let's have key be my actual field. Maybe I should actually call it field. We'll go with it. And it could be anything as well. It could be a list. It could be a Boolean. It could be list of list. Right. Doo-doo. I'm gonna make a double list. You see 4, 5, 6. If I run that and actually print it in my last line, you can see that it has associated key and then corresponding values. It could also, again, the corresponding value can be anything. Something fun about dictionaries that you should be careful of is that almost anything can be a key. So I could actually have 0 be a key as well. String. And so you can see that right over here. In my field is that an integer and a mixture of strings as well as other things could also be keys in a dictionary. Just be mindful, probably don't do that. But I did want to show you that it is possible. And this is possible because dictionaries aren't ordered. They are referred to by their keys. So like calling 0 will not be like, oh, I'll get the first thing I put in. It will be in reference to the key that you assigned it to be. Okay. How do we call things outside of a dictionary? It's once again with square brackets and the corresponding field item. So if I wanted to grab out that 1, 2, 3 list up here, you just need to call that with the square brackets, and there you have it. As also, please note again, like I said, you have those integers. You can also call it out. It looks like it's a list call, but it's actually calling the field for a dictionary. And you can get even weirder where it's like, I don't know, 1.2, a float. And then I'm going to call. Like that works too, which looks odd, even to me. Okay. Just looking through my things to make sure that this is all okay. Any questions so far, or anything that I've covered that was too quick?
And real quick, for those of you on Zoom, please ask your questions in the Chang intro Python on the general channel. But we got a question. Could you explain an example of why we want to use dictionaries?
So the differences between, I think the biggest key difference would probably be your selection if you wanted to be mutable or be able to be changed. Between a dictionary, your choices are between a dictionary and probably a list. If you go back to the list, it's basically just an ordered collection of things. If there were multiple things, like you could indeed, I'm gonna make this really ugly looking, like put another list here, another list. If I wanted to, I could do that. You're just gonna have to memorize that's gonna be the third index inside your list and sort of hope that you don't forget. I tend to. So it becomes a little bit easier when you give these things a name or a field to refer to them as. So think of it as right, if you had a CSV or like a table-like thing and you wanted to know what column and numbers these things refer to, it would be easier to have a header for that column, right? Instead of just being like, oh, it's the third one. Yeah, okay, right. It'd be easier just go like, oh, this third column refers to, I don't know, fMRI time series from this particular voxel. It just makes things a little bit simpler to remember. It also, I also think that it can get really unwieldy if you do lists of lists of lists. And that's sort of why we'll go to NumPy in a second, where we talk about matrices and things that are a bit more larger in shape. Another question in chat?
Can you talk a bit about the differences between R and when it could be better to use R or Python for your data analysis? Or
So I think the biggest difference is that, although the difference is getting smaller each and every single day, is that R was originally built to be a statistical software powerhouse, basically. Like all your linear models, all your linear mixed models, all of your Bayesian estimates, as well as with the implementation of tidyverse in R, if you guys are familiar with that, it makes like munging and ingesting data, especially in tabular format, incredibly easy and incredibly simple. Python also has something similar. They have pandas, and I believe there's and SciPy implementations of some of the same analysis, although I think there's a few differences here and there. They can do all the same thing. You can do all the same things. Like if you take it as a coding example, if you know something in R, you want to re-implement it in Python, that's actually an excellent way to figure it out. R's ecosystem is more built though to do those analyses like really, really efficiently. And the way that they all are sort of within its own ecosystem. I think Python's still in the point where it's like, it's hodgepodging a little bit. This package here, this package there, this implementation here, custom code. and in order to produce similar results of high quality, I think. And so for me, when I think about, but like once you get familiar with both, they can both, again, I reiterate, Swiss Army knife, it can do it. It can do it if you want to. But I do think that Python is a bit stronger when it comes to munging more data. R is actually quite slow. I know it's built on top of, a lot of its implementations are actually in compiled C as well. But I think the way that R and its interactiveness is a bit kludgy. It is quite slow as well. So Python actually wins out in speed in this case. But I do love how when beginners ask these questions or people who are a little bit unfamiliar with one or the other, just learning the basics or trying to translate from one coding language to the other is actually an excellent learning moment. Like that's how I learned these different languages as well. It's just that I learned R in my stats class and then I was like, all right, I learned, but I'm using Python in my lab. Why don't I just, make a project where I just try to implement and get the same numbers off the same data table? And that was like a really big pivotal learning moment for myself. Thank you for that question. Anything else in chat or in person? Cool.
Wait,
All right.
quick question. Can you hear me?
Yes, I can.
So I noticed that syntax wise, there's no like semicolons, which kind of coming from MATLAB, you kind of have to semicolon everything. So in Python, do you only use like semicolons, for example, when you like concatenate or start like a new row in a table, perhaps? Or like when would you use semicolons?
I only see semicolons when people really want to be tricky and do things like this. Hopefully you can see my screen. And they want to make like the one line, like 2 lines of code into 1 line. Don't do this. It hinders readability. It hinders readability.
So
But
for the sake of Python, like there's pretty much no use for semicolons then, right?
I don't believe so.
Okay,
It's mostly
awesome.
just commas.
Cool, thanks.
Of course, thank you for that question. And by default, Python is a quieter coding language than MATLAB if you don't forget your semicolons. Okay, so we have our basic data types down, and just as a reminder, type is your friend and favor to remind yourself what kind of data type you do have and what for what variable. All right, moving on very quickly to control structures or structure implementation. So Python is very strict about indentation, and you'll see what I mean with my if, else if, and else statements. So if condition A, colon, and then print, I don't know, condition A, we're just gonna make things up as we go. Print just to print to the console. We have elif for else if, and then condition B, print condition, make it a string, condition B. And then of course we have our else, again, with a colon at the end, print else. If you are familiar with other coding languages, then this will be pretty familiar to you in terms of like, right, your is, else ifs, else, or just if statements. You don't have to have any of the else or elifs, but this is just essentially how it's formatted. So if true, let's say, just to make sure that I print, and then false, just to make sure I don't error myself, it'll print condition A. And if I flip this around, if false, just so we can flip back and forth, true, right? We go to condition B. If false, we have our else as well. Just similar control structures. It's just that these indents here in Python matter. These indents here in Python matter, and they will yell at you basically. So let me do that. You can actually see it. Indentation error, expected an indented block after if statement on line 1. If this is considered to be bad syntax. I know some languages it does not matter. You could munge and like basically make it a 1-liner if you really wanted to. Again, Python enforces, one of the philosophies of Python is trying to enforce readability through syntax choices. So indentations really are here to help you make sure that you are following its structure and control rules. Okay, good point, good moment to also introduce our Boolean operators. So true or true, we have our usual line for our ors. We also have our amperstamps for our ands, false, our usual ones, as well as, let me just put these out here just so people can still see them while as I'm typing. We also have our not. I think this is probably the most fun thing I learned about Python when I was first going. It's like, this is very readable, right? There's no tilde, there's no exclamation point. It's just not true. or not whatever, or does not equal to, that kind of thing. And this is also, again, a Python choice to try to make things and operations, especially logical ones, more readable to a basic beginner. Okay. You can do, just to make sure I say it out loud, at least, we can also do our regular less than, greater than, or equal, right, operations if we want to have these operate on integers or floats or numeric types as well. Okay. Last but not least, in terms of the basic structures we should know in Python, doing a quick double check. Yep. Doing a quick double check is that we have our for loops. So for, I'm going to be very bad about this, elements, I don't usually type element, in, let's say, a list, I'm just going to give it 1, 2, 3. I could have assigned my list again, just to be extra verbose. 2, 3. And right, replace that over here with my list. Let's actually do that. Let's just print each element. We have 1, 2, and 3. Note, for some languages, you can't actually just iterate over the listed item or the ordered item. You actually have to refer to them by their index. You can do that as well. But by default, if something is iterable, like it has some sort of order or there's many items in a collection of things, Python will automatically try to implement it by iterating through its individual items. So like I mentioned just in a second ago, let me comment this out so we can see the next one. For I in range, my list is something that you might also want to know and also not have random L's everywhere. Oh, I forget. For. Oh, gosh. Sorry, my bad. Len, for range in length of my list, it gives you essentially the index orders instead. So I'm using I because people tend to do that, but index value. And so instead of just having printed that, my list, right, you can index through. I'll put just space. Starting to look more and more ugly now that I look at it. There, print a space between the index and the actual value that's inside the list, right? Instead of referring to my elements in list, is compare the first for loop versus the second. The first one, I'm iterating through the actual values itself. The second one using range, which basically produces the range from 0 to length of my list, which is 3, but it starts at 0, so 0, 1, 2. Let's actually just write that in. Format the string, index. I'll explain that in a moment. Okay. Just to be very clear about what I'm doing, right? Instead of going through each element at a time by itself natively through the list, we're referring to it by its index instead. So you can do something very similar to this. What I did right here for printing the string, instead of just printing the value, I gave it a formatted string. That's what this F stands for, right before the quotes for the string, actual string components, and then curly braces will basically fill in the blank for you. So if you're used to like sprintf or fprintf in other languages, very similar. I just put in the actual variable itself instead of having like %s or something like that. And so this gives me a really quick index and value correspondingly. Another way to do this, as you can sort of tell with any coding language, there's many ways to do many things. For I and value in enumerate, my list, enumerate the function basically packages up the value that's in the list with its index. So let's do a copy and paste here. Copy and paste, uncomment, on index because it'll yell at me. So my index is still I, excellent. Instead of value, having to index into my list, I can just print out value because that is my assigned iterative at that moment. So just giving you multiple ways to iterate through things, you can clearly see that the power in for loops is still obvious and present in a lot of different ways, just in Python as well. Any questions? I went through that pretty quickly. Any questions about this, either in chat or in person? Something else that you might see in terms of iteratives, just one last helpful function, hopefully. Let me actually start a new cell before I do too many things. List 1, our usual 1, 2, 3, list 2, 4, 5, 6. For, okay, X and Y, I apologize for these single line variables. In zip, list 1, list 2. Zip basically, just like a zipping, you compress the two together and you basically match up its ordered pairs with each other. So if I were to print X and Y, I'm just going to separate them by a comma and run them. We have together, we are iterating through list 1 and list 2 at the same time, where the values from list 1 are assigned to X and the values from list Y are assigned to X for 1 and Y for 2. You'll see this sometimes as well, just to do, instead of having to go like for list 1, do the thing, for list 2, do the thing. If they come paired, you can do them together.
Does it complain if the lists aren't equally linked?
Let's check. It does not, so be careful. It will only match up the pairs that it does have for what is the lesser of the two. I know some like languages will like, they'll do the longer and then they'll like repeat some values, but Python sort of stops where the batch stops. Okay. These are just some of the most common kind of looping functions that we have as well in conjunction with our for loops. And I will say something else that is incredibly Pythonic. Every single time I go through this, I always get a little worried, but we also have something called list comprehension. Basically taking a for loop and then making it a one-liner. So let's see, how should we do this? So let's have a string called, it's my name. Hello, my name's Kelly. And I want to, let's say, if I were to do a for loop through that character char in my string, basically looping through every single letter. Let's first print it just to see what's happening. Oh, my name with vertical now. Excellent. And so let's say, okay, hopefully there's a bit more use case when it's not just my name, but let's say I want to filter out this string such that it only has, I think the most common letter in my name is L. So let's go with that. Let's only filter out my L's here. Okay, let's build it up. Maybe let's start a new string. These are some excellent names, by the way. If, right, inside my for loop, I'm typing an if char equals L. Okay, new string plus equals, oh, my string. Oh gosh, these are some terrible names. New string plus the character. Let's see what happens. New string. So basically what I just wrote is, okay, I'm going to filter out from the original string into this new string variable, hopefully just my L's. Oh, yay. Excellent. We did do that. I was having a moment there. But okay, let me show you a few shorthand things that we could do here if we wanted to do it this way. Instead of doing equals plus, if it's like equals itself plus, you've probably seen a shorthand version of this as well. Plus equals is a shorthand notation for that. Double check my own self. Yes, that's still correct. Excellent. But this, for just me filtering out my L's, one that took about like 5 lines, not excellent. There are obviously methods for strings that do this quickly. There's also regular expressions that can do this quickly if you know them as well. But just sort of as an example for what I mean by list comprehension is, let's say, let's have my new string variable equals, I'm just going to put it into a list, char, for char in my string. Hopefully this still looks familiar. This part right here is just for my iterative item in whatever I'm iterating over. And I want the char character, I want my iterative if char equals L. So let's actually make sure I can do this live and okay. I hit L. But yeah, I get my 2 L's, not in a list format, but I can also just compress that later. Yes.
I see that this is more concise in terms of number of lines, but isn't it potentially harder to read?
I think for this example, not excellent, but but yes, there is that back and forth between readability and then what in the nonsense is this. I will say this is pretty good for generating lists. So let's say you have a really large matrix of lists, and you want to unzip them basically flatten it out. There are some methods out there, but let's say you don't know them off the top of your head. This is a fairly quick way once you get a little bit more familiar with reading how Python does things. Again, Not for everyone. I have friends who, like, to this day, after 10 years of learning Python, hate list comprehensions. And then I have people who love them. It's something we call a little bit syntactic sugar, where it could look really concise and pretty if you know what you're talking about, or it could look terrible. It's up to you. I at this point would start commenting things being like, I'm filtering for L's in my string. In my string or whatever, I would start putting comments, especially if you want to do these back to back to back. The one other powerful thing is that it's not just lists you can make, you can also make dictionaries. That's also part of it. So new dictionary, let's say in curly braces, just like dictionaries. My key can be my character, and I'm just going to be like, okay, I don't know, hello. For char in my string, if char equals. Oh gosh, there's two L's, hold on. Let's ignore that for a second. Oh, new dict, not my dict. All of a sudden, there's Kelly Chang. Please note, no double L's. You can only have one field per dictionary that matches up. Yes.
So like do this comprehension, like search for a capital letter as well as a lowercase letter. Like, so hypothetically, you say that your name was Lily,
Mm-hmm.
and that
Mm-hmm.
you essentially search for else.
Not a comma, an or. So I'm going to put it in parentheses here for my first if condition, just so you can see it a bit more clearly up here. You see the parentheses, and then you can do or char equals. Let's do my capital K because I know I have that. And print that and maybe suppress the last one just so we have a bit cleaner. You can see how if I copy and pasted this, copy, comment, if, right, first condition or second condition, if both, or if one or the other is true, put it into my new string or my new list. You can also, please Google this because I can never remember the order, but you can do like else's in here as well, but it gets like, you're starting to lose me too as well. I try to stick with just an if, just to filter things, but you can do like, oh, if, else, plus whatever, it's just like, it can get multi-line, and at that point, what are you doing? Mhm.
Someone online asked if you could talk a little bit about classes and whether and when it's necessary to use classes. We may get to that later.
Mhm. Once again, excellent question. You are interpreting exactly what's happening, hopefully a little bit later. But essentially, classes become more and more important once you get more and more into like packaged code. Like, okay, you want to just do this stuff that I've been showing you so far. This is like the fundamentals, right? I know my variables, I know my variable types at its raw, like, right, the most basic, oh gosh, what are they called again? I can't remember. But at the most basic class types, like your ints, your floats, your strings. Honestly, it should be characters, but then strings. It gets more complicated when we go into other packages and they have things like, oh, I don't know. I have a library called zoo. And in my package called zoo, I have an animal class. That animal class can take on attributes of a horse, a donkey, whatever, right? Each of these things will have their different methods. And especially if you're interacting with something you pulled open source offline, you may not initially know that this class has these options unless you've extensively dug through documentation about what each one does. It becomes more obvious when you're interacting with a class rather than something that's native or as fundamental as these particular data types we have. And just like I was mentioning, let's actually segue a little bit into examining some of the attributes and methods for lists. So what do I have as a list? New string. What do I have in here? Scroll. I just called dir the function. I have things like append. I can append extra items at the end to the list rather than having to assign it to an index. I can clear it. I can also copy it, a shallow copy, count how many whatevers are inside my list, right? These methods and attributes are specific to list classes. Let's compare that to, I'm going to open a cell underneath. Oh gosh, what did I have as a dictionary? Yes, neither. This is what happens when you name things funny. I'm gonna also take a look at these guys as well. You'll scroll down. We have all those underscore stuff, and I can talk about them later. But you also have in dictionaries a get based off key. What are your keys inside your dictionary, right? These are not the same methods that are associated with lists because lists don't have keys. Lists don't have paired key values, right? Or you can have update where you want to update both the key and value at the same time. These classes have their different methods, and you can do different things with them because they're different classes. I know it sounds a little circular that way, but that's sort of the basis of it, right? My animal example, horses have 4 legs. You can have a thing that says has 4 legs as a method, be like, yes, reports back true to you. And I don't know, I query a fish class thing and it's like, has 4 legs? No, right? Different classes have different ways to interact with them, as well as different attributes that will report back with how you interact with other code. Again, we'll segue this a little bit into when we talk more about, let's say, NumPy.
Can I ask what the significance of the underscores are? I know you're gonna talk about that later, but.
No, this is,
Seeing a mix on the screen, are those a delimiter for that particular operation, or is that, can you explain?
no, of course, it's a little bit more advanced, but I'm glad you bring it up. So you'll see these underscore whatevers a lot. And basically these are defaults. Or sort of hidden classes or attributes. You do have access to them. It's implicitly understood when you're coding in Python, the underscore is supposed to be hidden or don't touch. It's sort of like from one coder to another. If I do something here, don't touch it. It's sort of intrinsic to the class of the thing. So
But
what
you can use it, right?
you can also modify it yourself if you wanted to rewrite the class, let's say. So if I wanted to rewrite a list thing, like my list class, I can use one of these as well. It's just, this is more of a politeness to say like, oh, these are private. But what they do is like, let's say this is right here, the underscore GT that I have highlighted. It's actually what happens to the list if I were to perform a greater than operation on it. Or if I wanted to do a multiplication to it. Basically, these are basic things. So for integers, the greater than would be, okay, I compare the one thing to another thing. For a list though, how would we do that? We sort of have to give it that operation. It's like, oh, maybe I compare the first item to the second item. You have to sort of code that behavior.
Then the ones that are below in that list there on the screen, like copy, for example, does not have underscore. So that means it's available to be modified. It's, I don't understand the distinction between the private versus the not private.
It's more of it's more, you can modify all of these, but it's again, more of a courtesy, I would say. Yeah.
So Python doesn't actually have a concept of private or public, not built into the language. You generally use underscores to indicate that you want something to be private for other programs to know it's like private to the class. But the double underscores, specifically all these things with double underscores on either side, that is just a convention that Python decided to use to indicate that this is like a built-in function. So like underscore str underscore, that's the function that gets called when you call the string function on an object. And underneath the hood, Python goes and calls that method. So the underscore methods are largely things that are needed to make the class work, that Python needs to make the class work, that are kind of hidden from you, and more advanced usages, like maybe overlook this.
And to use them, you don't put in the underscore, you just say str, whatever.
Yeah, can you show them like str?
Yes, yeah. So
I'm sorry to be.
No.
I want to try to understand this.
So
that would confuse the hell out of me.
no, this is something that when I first learned it, I was also like, why is there no private things I just can't touch? Because Python's just not built that way. So when I call string on my list of strings, just because this is what we're currently working with, it just prints out my list of strings. If you notice the single double quotes, it's a string now. Like the whole list with its brackets is a string. That's the convention when you call this. No, correct me if I'm wrong, but I could technically still do it. Same thing. It's just that this is the behavior this particular object or class will have if you call basic built-in features like len, string, int, like stuff like that, a greater than, equivalence. How do I compare these two things? It's the built-in behavior, I think, that makes the class what it is. Of course, if people know other coding languages, this is the distinction between the coding languages building in private features or attributes that you cannot touch. Unless you wrote the code, you cannot touch, versus public attributes or methods as well. For people who know. If you don't, you can talk to me afterwards about what that means. Okay. Awesome. Checking the time. I have 30 minutes to somewhat talk about NumPy. I'm going to, as you can tell, we've gone actually quite a bit of ways and printed a lot of things. So I'm just going to open a new notebook for us. Just as a reminder, most of the things and more are covered in that 01 Basics Python notebook with more text to explain things for you. It's just I feel like my time is better spent if I answer questions as well as show you live demos rather than going through a textbook. So let me just open up a new notebook for you. I'm going to call it MP. Oh, please, no, don't do this. Intro NumPy. I'm worried it's going to think it's a variable. Okay, so that was mostly basic functions that are built into Python natively, and there are more that, again, like I mentioned, I didn't cover. However, what immediately once you start coding in Python, you'll recognize that the basic features of Python are not enough to like do almost anything, to be quite honest, including like pathing or like just finding strings or other files or things like that. Now, so the first package you'll probably be introduced to, if you have not already been introduced to, is NumPy. So NumPy is a package. I should actually do this. Hopefully people can see my cat, but also a new tab, numpy.org. NumPy, just to show you like what I mean about interacting with new packages, not all packages are documented this pretty. Oftentimes they're not. The NumPy is so fundamental, SciPy as well as like other things like scikit-learn or image.io or something like that. These are so well documented because everyone uses it. If you go off into the deep end and use someone else's random package that has not been documented nicely, do not expect documentation this pretty. But usually these days, most packages have some website that you can point to and orient yourself to. And when it teaches you how to install it, how to contribute, news about it, especially because I think NumPy 2 point something came out recently and wanted to destroy all my code. So versions are important to keep track of if you are using them of particular types. One of the really important things about documentation, especially just knowing that these sites exist, is that I don't know every function in NumPy. I don't think anyone besides the people who made NumPy know what's in NumPy. Like, it's almost the same universal feeling when you interact with a new package. So usually I try to like go to the documentation, navigate around its tabs. Usually if you see the words API or documentation, tutorials, these are excellent places to start for packages that you know nothing about. Again, NumPy is so like universal. I think most people know most things about it. But as a general example, I'm also going to zoom in a little. Oftentimes they'll have like, oh, what are array objects like in NumPy? How do I interact with them? How do I do data types? Iterating over arrays, right? There's tutorials. There's ways that they broke up NumPy with C API. Like we were mentioning before, you can interact with C-based objects through Python if you learn Python first and don't want to learn C. Stuff like this, and you can sort of dig through their API of how to implement it. And again, this is sort of how you learn about functions, or you ask ChatGPT, or you ask Copilot, I believe. They'll autofill a lot of these things for you. I still find really good usage from just reading through APIs, just to know what's there. Like, oh, like I mentioned, I don't want to do another fast Fourier transform. I don't want to do it raw. I just want to hopefully have someone's function built in for me to do it. I would just look it up instead of having to just like reinvent the wheel, essentially. NumPy for MATLAB users. Excellent, because NumPy was made, I think primarily historically speaking, to try to match matrix operations that MATLAB could do seamlessly that that native Python does not want to do natively. And I'll show you an example of that in a second. All right, enough about the documentation, although please have and hold that. That is important to come back to for any package, is that how do we import or use NumPy? Well, let me actually back up one step and go to our terminal. If we don't have a package already installed, and you might not even know how to install a package or not know what packages are in your environment, you can open up your terminal of some sort, and hopefully your Python, and in our case, in our Jupyter Hub, you know that we have something because we have this indication right here. If you guys are familiar with Conda environments, basically these are just environments of Python packages that can be like named. And so we're in the environment called Notebook. And from here, we can do like pip install. I think, I forget what pip is short for. Just install for Python packages, I think. Python install packages. That might actually be it. And we can type install NumPy. Hit enter. Thank goodness that we already have this installed. It will also take forever. But if it didn't, it would download from wherever it's stored and then install it onto your instance. If you guys need to install other things, this will be how you do it. You interact through the terminal, and you can then have it end to hold once you're in your Python instance. So now that I verified that NumPy is in there, I can do import some package. I can import NumPy. If I run that and it doesn't crash on me, that means I have it. Now you'll also see import NumPy as NP. We want to call things from within the package. So like, I don't know, np.mean, np.median, like some simple functions. Instead of having to type NumPy all the time, people abbreviate it to just be NP. You'll see every package sort of has its preferred acronyms, and you'll see these commonly. Like I could have just called this Z for unknown, unholy reasons, but that no one knows about that, and everyone calls it NP. And so that way, I can call like NP mean. Okay, I'm missing an argument for my mean, but yeah, now I have access to the NumPy functions and its array of associated sub-libraries and sub-APIs as well. All right, why do we need NumPy? Even though we can already do things like, welcome back my list, 1, 2, 3. We have lists. Why can't we just work on this like it's a vector? Well, Python hates that. I want a +1 to this list. It starts yelling at me. It starts yelling at me. Type error. Can only concatenate lists, not int to lists. It's trying to think of like, oh, it wants to append that 1 at the end of the list. And you're like, no, I just want to add 1. I want to like in R, if I were to do an +1, it would do an element wise +1, right? It would do a multiplication of ×2 on each of its individual elements. However, the native Python types don't operate like that. They operate, as you can tell, through concatenations, through combinations. It's not the native way it works. And that's why we need NumPy. Because instead of trying to do this on my list, let me just do this, my array. I can do NP array. And so I'm going to define a NumPy array, and I'm going to give it a list of 1, 2, and 3. I'm going to print my array. And you can sort of start to see the difference. One, it prints out a little bit different. It's not straight up just a list of 1, 2, and 3. It has the word array in front of it, and then 1, 2, and 3. So as sort of implied underneath the hood, the print function has been modified for the NumPy array to print on top with the word array to signify to you that this is a NumPy array. And so, okay, great. Let me do that +1. Oh, whew. Math is working again. Vector math is working element wise again. And now you're like, oh, okay. This is the difference between native lists in Python, the class, versus NumPy, the array. The behaviors are different when I want to do specific things to it. So if I wanted to do a <1 on my list, it's like, what is this? Less than is not supported between instances of lists and int. If I wanted to do, I guess <2 would be a better one. Oh, okay. I can do an element-wise comparison and got booleans out of all of those instead of having like crazy, I don't know what to do with the less than sign. Underneath the hood, the __LT___ has code that makes these different classes operate differently on what you think is pretty basic behavior, or like what's fundamental behavior to this particular class. And you can now sort of start to appreciate, okay, moving away from this, although those are still useful, tuples are still useful, dictionaries are still useful. You can also assign NumPy arrays into dictionaries as well, just in case you were worried about that. Okay, now that we have array types, what can we do? Well, my array, let's take a look. Let's take a look at some of the methods. Oh, there's a capital T right up here. There's also obviously the built-ins. Scroll. We have a lot of these things now. Some of these might be familiar in terms of methods to you, especially if it's like an array kind of thing or a vector. All, well, maybe it's like, oh, if all of the things in the array equals something or less than greater than. Any arg sort. Oh, I can sort my vectors now. Clip, choose, conjugates, right? You can do a lot more things. The list is actually now much longer, as you sort of saw compared to the list, native lists before. And this is sort of what you get by adding this class or this NumPy functionality on top. Okay. So some things that you might want to know about, once I get all the way back to the top here, comment that out. Some very common attributes that you might want to know the importance of. Shape is going to become your best friend. So what is the shape of my array? Oh, I have it as 1, 2, and 3. Similarly, right, this is a vector, so it only has 1 dimension. There's only 3 elements. We can start making things more complicated by testing my abilities to make multi-line arrays. array equals, okay, NG, great. You're gonna start seeing me type really formulaically. Ah. You can also see me also, my MATLAB is showing as well, where I'm trying to make my things look like a matrix. You can now have arrays or 2D arrays or ND arrays by what originally would have been lists of lists, where you would have to subset into the list. Now you have them as a matrix form where there's 2 rows, 3 columns. Hopefully this is familiar to most people, and I don't think I can type a 3D array. I don't think I've ever been able to type a 3D array. So we're not gonna do that. But right, shape will tell you the shape of this matrix. I should rename it to be my matrix instead of array, but you can sort of get the gist of what I'm trying to convey here, is that now you're able to do these things and you can interact with them as you would matrices. Again, if you're familiar with both R and or MATLAB, or honestly any other coding language. You can, was there a question in chat?
No, I was just gonna suggest you talk about the versus columns, since we have some MATLAB.
Yeah. So, oh, one last thing before I move on, is that you also have D type. Just to show you the types of data classes inside the NumPy array, you have them as, they're being represented as int64. So integers represented in 64 bytes. You can obviously go down or up or have floats, things like that. Just wanted to make sure that these are very common attributes that you can read out of arrays. Okay. So what Noah was saying was basically rows versus columns. And so before, when we had lists, we could subset them in by the zero-based indexing. And if you are again familiar with MATLAB or other programming languages, you can like grab whole rows, you can grab whole columns. Very similar here. You again, zero-based indexing. Let me say I want to grab the first row, 0, comma, and then colon for grab all of the first row, control. It turns it into something also to check, especially when you subset things like this, is like you can change the shape of it as well. Please notice I'm also just chaining. This is also something that's really beautiful about Python, is that, oh, I subset and I also chain that shape, because that subset was still also a NumPy array. I can keep on doing these things ad nauseum, but also please limit yourself to probably 2, just in case. But so you can subset things like that. So this will grab you all of the row, first row, my array, all of the second column. Yay, okay. I can still do math. You can also slice things where it's like, okay, I just want the back 2. So all of the rows and columns 2 through 3. Oh gosh. There you are, 3. And you sort of note that even I made a mistake right there. When you subset things, it's inclusive of the first number, exclusive of the second ending number. So when I accidentally did 2 right there, it only really just got me it's still just that second column, because 2 is exclusive. I won't actually go that far. So 3 would include the second index or third column in our case. So be mindful, it's inclusive, so square brackets, parentheses open on the other side. Also note, if you do this, shape, it's a 2 by 2, excellent, excellent. So I often do things like that where it's like, oh, okay, make sure I grab the right part of it, as well as make sure I have the right shape that I assume these things to be in. So subset array, just assign it to be a variable. Subset array, make sure it's still the same thing. I can basically do other operations. So flatten is also something you'll probably want to see. Flatten will unroll the array, and it will be row wise. In this case, you see the 2, 3. Those were the first 2 instead of column wise, in case people were familiar with MATLAB doing it column wise. It does it the other way. Also, you can do fun things where you can keep on chaining these additional attributes so long as you sort of know what you're doing. You can flatten it, check the shape. You can check the D type, make sure everything's still the same thing. Just some commands that you will become very, very familiar with as you work with NumPy arrays. Okay. Taking a moment to breathe. Also, the fact that we have 15 minutes left. Are there any questions before I move on? Chewing. Yes, I see a hand.
You just keep adding.
Oh, yeah, you can definitely keep on doing that. You can do multi-lines of it too. Should you? No. Again, readability versus do you want to just keep on chaining into the right-hand side of your screen?
So more lines is preferable.
Python tends to prefer more lines for readability. Like that's its philosophy. That's why its syntax is built the way it is. Like I definitely could, like I can keep on doing. I put a parentheses at the beginning just so I can show you that I could technically multi-line this too. Should you do this again? No. So if you can make a way to make it readable, like I don't know if anyone knows like JavaScript and they have that dot syntax where you throw things forward. This is like very similar where you match up the dots. Again, my coding background showing, but like don't do this. Not recommended. It's more preferable if you have multiple lines and you assign the things that you want to assign. Especially if you're just beginning, it can get quite confusing because some people, especially when they get into Python, it becomes more left to right reading. Like, oh, subset my array, flatten it, get the shape, right? You're reading left to right. Some people, when they first learn it, are still stuck in the read the inner to the outer for like the function calls. It becomes like, right, a little bit of back and forth between that as well. Okay. Some other fun things that you probably want to know. By the way, if you don't want to keep on clicking add a new cell, I've just been doing escape B for put a new cell to the below. You can also do escape A and it puts a cell to the top of where your cursor is. I'm just doing a lot of shortcuts. Actually, if I remember correctly, yeah, under help, there's your keyboard shortcuts, by the way, just in case you needed them. If you get really familiar with this Jupyter interface, you can do a lot of crazy copy and pasting. There's also, as always, with these GUIs kind of thing, you also have your options to do them. Click by mouse click over here as well. Just going to get rid of that extra one right there. Okay. So some initialization features that you might want to know. So we have NumPy zeros, where we can also create a new array. Oh, gosh. Maybe something else than that. New arrays of a particular shape, let's say 10 by 10 by 5. If you notice here, this is the first argument, just telling you the shape of this new matrix that we want. It's also a tuple, keep in mind. Don't want to print all that zeros, but we also have, right, we make a new array, we can initialize it with empties. Okay, I do want to print it to you, but look at that. A 3D matrix that I cannot type for the life of me. But essentially, you can make things like this. You also have your, forgot if it's just one now or not, with an S. So it's not callable. NAS. Can't remember. Oh, wait. Sorry. My MATLAB is showing as well. NP-NAS for not a number, or we can probably do something like this. Change that to ones. Now we have a giant matrix of NAS. We have some constants in NumPy that aren't really built into Python, so not a numbers. Pi is in there too. E, the exponent E. Few other ones I can't remember off the top of my head, but essentially, right, your sines, your cosines, your tangents, all of these things, all your normal mathematical functions that you think would be base but are not base in Python, go figure. And these are available to you in NumPy. So if you wanted to initialize an array, you can basically call the shape of it, whether you want the NAS or not, up to you, or you can have it be zeros, have it be ones. If you're familiar with MATLAB, these things are starting to become very familiar or very, you've seen them before in different ways. Okay.
For functions like mean, stamp std, etc., do these exist outside of packages? Because they exist in pandas and NumPy. If not, why not? Why don't they exist?
So that is one of the downsides. So the question was basically, okay, NumPy has a mean function. So does the pandas package, by the way, just to let you know that multiple packages have the same function. They may implement it differently underneath the hood, but like supposedly, if all things good, they do the same thing. It sort of depends. It sometimes will, so just to take a small tangent into package talk, right, I can use NumPy on pandas things. We'll talk about pandas a little bit later, but we can do NumPy on panda things. We can do panda things on NumPy things. They're built because they're such large packages to talk to each other. And I believe there's a lot of the same coders and scripters that crosstalk on these packages. So they know what they're talking about. And sometimes there's packages that are built completely, let's say, on NumPy. Like, I think SciPy is almost like infrastructure one level up on NumPy. Yeah, so is pandas, right? Yeah. There's like a lot of packages like that where the dependencies are strong, like they're very strong. So why would we implement, let's say, the mean function twice? Like pandas.mean or numpy.mean. It's like, this is the same thing. And other functions like standard deviation, so on and so forth, summary, describe, things like that. Well, it's because these are built into the classes that each of these packages decide to implement. So pandas.mean works really, really well and quickly on pandas data frames or like panda tables. And they sort of don't think they can work, but they don't really work as well on NumPy arrays because pandas is thinking, oh, this mean function that I have implemented is for my pandas stuff. Well, NumPy is like, I'm more of a generalist. I will do anything. I will take the mean on any vector you give me along any axis that you give me. And that's sort of why pandas is built on top of NumPy. They're just exposing, they're both implementing the function, the same function sometimes. So they interact with class objects that they make better, as well as sometimes it's just to expose the underlying original function as well. So there are things you pick and choose. I actually, in my code, I'm not actually that straightforward. I sometimes use both. I sometimes don't keep track of what I'm doing, so long as hopefully the numbers are right. I'm not like too much of a stickler about these things either. Although there are some cases where you should be a bit careful because this is open source. I've tried to like pull like a PCA thing off of the internet once, and then it didn't give me the same numbers that SciPy did. And I started to distrust this other package that I downloaded. So be wary. Because it's open source, some things aren't validated. I do trust NumPy, I do trust pandas, I do trust SciPy, scikit-learn. This family of things I trust. But again, if you start going off into the weeds, sometimes I don't trust. It's also sort of similar with R packages. If anyone's familiar with trying to implement crazy statistics in R, it's the same thing. I don't trust that much when I'm out in the fringes. I would say pick and choose your favorite and what works in that moment for a variable. So like if I want to do a mean on a data frame, I would use pandas as mean rather than NumPy, just, as a choice. Thank you for that question. Okay. One nice thing. Let's see if this works. This is more of a, because we only have 9 minutes. Feel free to follow this or not. This is more of a, can I get this to work or not in like 9 minutes? Dun, 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 fingers crossed. I may not have installed it. Import. I did not. You get to watch me do this live. Pip install. Nice. This is what it would mostly look like if you're trying to pip install something that's a bit more heavy-handed. I'm just trying to download a data set.
What was I'm just gonna put it in the slides.
Oh yeah, for sure.
What was the library name?
Sorry, second.
Oh, yes.
NDS lib. You can also call the terminal from Jupyter as well, NDS lib. You can do that by having an exclamation point at the beginning. This is just because I learned it this way. I like to do it in the terminal just to keep my code separate from my installations in Bash or Linux versus my code in Python. But I've seen people do both where it's just like, I will use my, you can sort of see if I had that exclamation point, it's calling Bash or basically the terminal underneath the hood. And it's trying to reinstall the same exact package I just did. The reason why I also didn't want it was because this is really, really long. You can shorthand or make it scrollable. If you double click on the output cell, it'll tighten that up a little bit for you so you don't have it output all the way.
You can also add dash quiet.
Thank you. I don't tend to, mostly because I want to see if it's done it. I have no trust in code.
Okay.
But yeah, no, that's also something good if you want to suppress, right? There's most things have a dash quiet or dash q for most things. Now, if I run it, nsdlib import load data, I'm specifically from the NDS lib or that package importing a specific function. Instead of we saw import numpy as just to rename it, but you can also have done from numpy import mean, right? And you can just pull out just one function. You don't have to load the entire package if you didn't want to. Now, this is me really trying my best. Try to load some bold data. Load data, call that function. Call what is called bold numpy. Numpy. Give me an F name just so I don't destroy my computer. Fingers crossed, guys. See if this works. My old PI, my graduate mentor PI used to call doing this going off script, but cooking live. Like usually I have a baked turkey in the oven to show you things I practice, but this is sort of me going like off script. So if anything explodes, I'm sorry. Oh my, it worked. Yes. Bold, yes. Bold shape, even more yes. So you can sort of see, I was just downloading, there's a package called NDS Live. There's some extra play example data. There's a lot of libraries actually with just data sets in them that you're welcome to search online and you can download and you can play around with them. Highly encouraged for the actual hackathon portion. We'll talk more about obviously like the different kinds of data sets you can play with. There's also like baby data sets like this where I'm just loading in literally an XYZ and 180 time points of bold data. I'm also going to open up refresh. I hope. Yeah, I did. If you also notice something really nice about NumPy is like, right, sometimes you're working in your IDE and in your terminal and I want to save out my data in my NumPy arrays. I can save it out as a .mpy for NumPy Python. And it's actually, I don't actually know. Yeah, I can't open it. It encodes it into something that you can load back up again through NumPy, I believe, mp.load. Or something like that, it'll load in your variable again. So you can also save out things that NumPy provides for you, rather than a text file, rather than a CSV, although those are also options for you as well. These are also different ways to save and export data. I just wanted to show you that by assigning the F name, I just saved a .npy file out here in my directory. Okay, closing that out. We have NumPy bold, and so right, if we had bold data, just to sort of show you, I want all the X, all the Y, maybe I should do some spaces, all the Y, all the Z. These are some terrible spaces, Kelly. And then let's say the first 10 bold time points. Yeah, okay, I can do this sort of live. Just to show you, it's like, right, if you have bold data and you want to work on specific time points or you want to similar subsetting methods apply. And just to see if we're going to head in that direction, we can also get rid of all that subsetting. Do mean, because it is also a NumPy array. I should actually double check that, even though I called it. Type, bold. Okay, it is a NumPy array. If I know that's a NumPy array, then I know I have methods like mean on it. Let's take a mean along the last axis. Check the shape, right? I can still have my X, Y, and Z. I can take like the mean or median or whatever standard deviation along that time axis or my last axis. That's what the -1 is. You can do it obviously on the first. You can sort of see the numbers changing around with the shape, right? The X is gone, but the Y and Z are still there with the T. Stuff like that. I think standard deviation is STD. Yeah, right. Again, NumPy arrays, you could do all the math and all the matrix forms that you want on it. Please look into that in great detail. Part of the reason why I just wanted to show you this, import matplotlib. Matplotlib, I know this is installed as PLT. Matplotlib is almost like almost like the package name implies. At some point, someone was very fed up that there was no real basic plotting stuff. And they're like, why does MATLAB plot things, but Python can't? Well, here you go. Here's a package that does very similar MATLAB-like plotting. So some of the function names you'll probably be really familiar to you. I am show maybe mean axis -1. Think no. Oh no, plot bold. I need a slice. Plot bold, bold. All of X, all of Y. First. We'll see if this works. Plot bold. Yay. Okay, maybe not that slice, but you know what I mean. You have like baby bold data to play around with if you want to. Yeah, this is that last slice, isn't it? 10. Yay, brain. But yeah, no, so this is just a NumPy array, right? So if we load bold data into R, even MATLAB, Python, same thing. A block, a cube, 40 data. You can mess around with as you wish. And hopefully some people will do fMRI stuff in our hackathon. And so you can obviously inspect your data in this way as well. That was really quick live clicking. Next time you'll see me, I'll be lecturing about pandas and then plotting as well. This was just a quick preview of what's going to happen over there. Thank you for your questions and your attention, guys. We're at time.